Hello, everyone, and welcome to the first experiment in Chem 241. This is the determination of the distribution coefficient for benzoic acid in a water methylene dichloride system. Everything that you need for this experiment is in the fume hood. And the three solids that you're going to be using are, of course, benzoic acid, methylene dichloride, and a drying agent, sodium sulfate. So you've got plenty of time to do this experiment. You've got about 2 hours and 50 minutes. It's not going to take you that long, but relax, enjoy the lab. Don't rush through it, because if you try and rush, you're going to make a mistake. And then you're going to have to repeat it. And you're not going to learn anything. So just take your time when you do the experiment. Try to make some observations. You know, here's one of the chemicals, is benzoic acid. And you look at this, right? And you kind of notice that it looks different, right? Obviously, than this one, right? So this is kind of a powdery. It probably has a pretty high surface area compared to this one, right? Which is kind of a chunky or a granular. We say it's granular in nature. So now what this means is that when you weigh the benzoic acid, even though you're only going to use, I think it comes out to be 40 milligrams, you're going to have to calculate it. One of these chunks in here is probably a good 25 milligrams, so it's not going to take much, as opposed to something like this. You're going to have to use a little bit more of this as compared to benzoic acid. So you've got benzoic acid, you have sodium sulfate, which is a drying agent, which means it removes moisture from something, in this case, organic liquids. Believe it or not, even though organic liquids are insoluble in water, there's a certain amount of water that may get taken into the organic liquid, and you want to dry it. You want to take this out. If you don't, then when you evaporate your organic liquid, you'll have droplets of water in your sample. This is the liquid we're going to use. It's very volatile. It's a methylene dichloride. It is also slightly toxic. You don't want to be swallowing this or inhaling it. We'll use it in the hood. Because of its volatility, if you accidentally leave it open, if you leave the lid off after you use it, it's going to evaporate. Same thing with your sample. So make sure that, you know, when you use this, you cap the lid after you withdraw, you know, a certain amount of the methylene dichloride. CH2Cl2 is the formula for it. Okay, so those are the three compounds that we're going to use. And you're also going to use some pipettes. These are polyethylene, these are plastic disposable pipettes. And we also have some glass, we call these pasture pipettes. These are also disposable. When you finish using those, you can discard these into a waste beaker, which every hood has. It'll have a little red tag on it. And that's where you put glassware or, you know, droppers like this after you use them. Okay, so now let's take a look at what a conical vial is. There's a conical vial. We're going to use this to hold methylene dichloride, the benzoic acid, and water. And these are marked. I mean, sometimes the marking gets worn away, but this is a 5 ml. It may not say 5 ml on there, but you only have two sizes in your desk drawer. Every student has their own desk drawer underneath the fume hood, and those are color coded. So if you were in the lab for Monday, you know, it'll be a red stripe in there. Tuesday will be a different color. If you're in the afternoon, if you're in group B, then it'll be 2 stripes instead of 1. And this will be on your experiment. So only the student will use that drawer. So no one else, which is kind of nice. So that's your own personal laboratory desk drawer. So it's a 5 ml conical vial. And the other one that we're going to use is a 3 ml. Looks something like this. And sometimes, you know, the marking wears off. So this is a 3 ml. What do I have here? I got this one here. I guess they don't have the 3, right? Just the 2 right on there, but it's still a 3 ml vial. Now check these to make sure they're not chipped. I usually check the lab, you know, beforehand, but if one has gotten away from me, just look at the top of this, and you see how that's chipped there? It's a little chip mark on that, right? Now that's not sharp enough. Well, if you press hard, you could get cut on that. So be careful, right? You're not going to use this. If you have one like this in the desk drawer, I'll give you a brand new one. So be careful when you use these. The other thing is, if there is some kind of a chip here, then when you seal this and you have to agitate it, your volatile liquid will come out of the seal. So that's the other reason why you don't use a conical vial that is chipped. Okay, so we're going to weigh out a certain amount of benzoic acid. I think the experiment calls for 0.4, is it, don't quote me on this, 0.4 millimoles. We're going to use millimoles in the organic lab most of the time. And that's because we're only dealing in milligrams. So, you know, if you had a compound and its molar mass was 50, that would mean there'd be 50 grams in a mole. How many milligrams in a millimole? Still 50, except it's 50 milligrams. So it's very simple. So milligrams are to millimoles, but grams are to moles. You don't have to convert back and forth, right? It's simply millimoles and milligrams. All right, so there's your benzoic acid. You're going to weigh up a certain amount of this, and you're going to do this using a piece of weighing paper. Looks like this. And you just don't, you know, when you use this, you just don't fold it up. Say, I'm just going to fold it up, throw it on the analytical balance, and weigh something. No, there's a way that you fold this. Obviously, if I fold the paper like this, and I put something on here, I weigh it, right? And then I try and put this in the vial. You see the problem? I'm going to spill that on the desktop, and then you're going to get the wrong result. You're going to have to repeat it. So that's not the way to fold filter paper. You probably were taught this in General Chem. You take the filter paper, and what you do is fold corner to corner. So you're going to fold like this. Open it up. Then on the other one, corner to corner. This, you'll have to excuse the video a little bit because the rear camera on my Surface Pro, everything's backwards. So when my hand is coming in from the right-hand side, it actually shows it coming in from the left-hand side. And that's a real trip. But it corrects it when you get the video. So for you, it looks fine. But for me, everything's backwards. Even the labels are backwards. All right, you see the difference in the paper now? So a weighed sample, I'm not going to have any problems transferring the solid from the weighing paper into my reaction vial if you fold the filter paper correctly. Okay, folks, we're back. I have weighed out some benzoic acid. There it is in the 5 ml conical vial. You can just see it in the very bottom. There's not much in there, but you don't need much for this experiment. And to this, we're going to add methylene dichloride. And then we're going to stir it around, allow the benzoic acid to dissolve in the methylene dichloride, and then we're going to add water. And that will create a system that contains 2 liquids. One is methylene dichloride, the other is water. They are immiscible, which means they don't dissolve in one another. And the benzoic acid, upon stirring, will distribute itself between the 2 layers. So benzoic acid is here. Now we're going to have to cap this. So grab a cap, grab a liner. Now, if you look at the liners, you know, the liners, some of them have colors, some of them don't, right? So, you know, here's one and it's red on one side. Oh, it's red on the other side. So this one's got red on both sides. This one over here has got a shiny side and a dull side. Now, it turns out that for the liners that are used, there is a side to this that is coated with Teflon, and that's because Teflon is a very unreactive material. So when I cap the vial, if the Teflon faces the liquid on the inside, I never have to worry about that liquid etching or dissolving some of the liner. So you got to make sure that the Teflon faces your sample. Now, how do you tell? Well, in this case, you say, well, it's the dull side that faces down. Well, you know, how about this case over here, right? That looks kind of dull, that looks kind of shiny, right? So what you have to go by is the fact that it's the Teflon part that faces down, and that's the thinnest part. If you look at this edgewise, you're going to learn something in this experiment. if you take your time. If you look at it edgewise, you will see a very thin top layer. That's the Teflon, because Teflon's expensive, and that's always the thinnest part of the cap. So that's the Teflon. In this case, it looks like it's a dull side, but don't use that. You know, look at it and figure out which is the Teflon side, right? Let's take a look at this one. Sidewise, there's the Teflon. That's going to face down. But this one over here, well, this is easy because I can see this one. Guarantee this is the Teflon side that faces down. There's another one. So you can always dye this. So in this case, there's the Teflon, right? And that's the one that faces down. Now, in this case, this is easy because you can really spot the 2 layers. This is a lot more expensive than this because now I got 2 layers of Teflon. So obviously, you're going to see more of this in your kit. This is probably the least expensive. There shouldn't be any confusion when you look at this because you'll know which is the Teflon side. Okay, so this goes into your cap, like so, right? And you're going to be wearing gloves. I'm not wearing gloves because I'm trying to do this for my Surface Pro, and as I said, everything's backwards. So it takes a little time, but you're going to be wearing gloves just to be safe. Okay, folks, continuing on with the second part of the experiment. You're now going to place 600 microliters of methylene dichloride using an automatic delivery pipette into the conical vial containing the benzoic acid. So this is a automatic delivery pipette, right? They come in various sizes. There's a marking on the side here, which you can use to tell how much liquid you're taking out. Now, in this case, it looks like it's saying 100. See the red number here and the 2 numbers there. So it looks like 100. It's actually not 100. In this case, it's 1,000. Here's another one. 100. In this case, it's 100. So you say, well, how do I know? Well, what you have to do is look at the tip, right? And it says 100p. That means it's 100 microliter pipette. It will deliver from about 10 microliters to 100. In this particular case, that's 1,000p. So this will deliver about 100 microliters to 1,000. It's about 10% for the lower limit. So that's how you know which one is which. The other thing, if you look at the tip of this, see the difference between the 2 tips? So obviously, whatever this dispenses, the maximum limit's going to be less than something like this. Okay, you've probably used this in General Chem. If you haven't, don't worry about it. So the first thing you're going to have to do is set this and make sure you go the right direction, right? So that's 990. And carefully, don't go spinning things around, right? You always take your time, work carefully. So you're going to have to set this to 600 microliters. Cool, there it is. That's not 60, that's 600. So that's 600 microliters. We're going to use something called a pipette tip. If you get into some of the advanced labs, you know, they'll have this set up so you can just insert it like so. What I would do in this lab is to just take this and with your fingers, just make sure it's secure. If it's not secure, you know, if it's like something like this, right? And you can wiggle it, what's going to happen is you're going to end up with a pipette tip in the bottle of methylene dichloride, and you don't want this. So for this particular lab, I would just take my fingers wearing gloves and push this up a little bit. You don't have to jam it in there. Push a little bit so it's secure. See if that doesn't wiggle. All right, so this is set. Everything's ready to dispense 600 microliters of methylene dichloride into your conical vial. And then, of course, as soon as you dispense it, you're going to cap it because it is very volatile. If you leave it sit there for 5 minutes, it'll be gone. Okay, folks, so continuing, we've got our automatic delivery pipette, and we've got some pipettes here, pipette tips in a box. And you can just press down on this. I would make sure that this is secure. You can just test it a little bit, see how that wobbles off, right? So that's not secure. You can end up with this in the bobble. So just a little pressure like this. Now there's no wiggling back and forth. Now on the top of the pipette, right, there's two settings for the plunger. First setting, right, and second setting. So when you aspirate, that is when you withdraw a liquid into the pipette tip, you go down to the first setting, place the pipette tip into the liquid, and then draw up slowly. Okay, so first setting, then put the pipette tip into the liquid and draw up slowly. So you don't go like this and then like that. That's not gonna work, all right? So just easy does it, and then draw it up. When you dispense the liquid out of the tip, you're going to reverse the motion down to here, and then for that little extra drop that may be in the tip, you go down to the second stop. So again, to aspirate, that is to withdraw into the tip, first stop, draw it into the tip. To dispense it from the tip, first stop and second stop. And then on the side, there's a little button here. And what that does is, because if you were dealing with a corrosive liquid, you wouldn't want to be touching this to change tips. So if you're going from one liquid to another, how do you get rid of the tip? Well, what you're going to do is the top button, you just press this and that will eject the tip. All right, and you can inject it right into you're going to have a disposable waste beaker, so you can dispose of the tip in here without touching it. And that's what you do if you've got a fairly corrosive liquid. So we're ready to take the sample out. The pipette is set for 600 microliters. You have your methylene dichloride next to your conical vial with the benzoic acid. So wearing gloves, and I'm not wearing gloves, but again, I'm trying to do this and it's all backwards. So if I was wearing gloves, I'd really have a problem. So this is pretty volatile. I mean, the methylene dichloride, you'll notice that when you, tip to the first stop into the liquid and withdraw, and now I'm going to take it, see how it drips out of there? So if I try and transfer like this, I'm going to spill it all over the table. So the idea, now notice that it's perpendicular to the table. I sent you a link to a little film on how to handle a pipette, so make sure you watch that. So it's just, I'm going to aspirate, which means I draw it in slowly. See, now it's slowing down. Try it again. So you do this 2 or 3 times. Right? See how it's really slowing down? So now I'm confident, aspirate, I'm confident that I can do this, isn't that nice? Without dripping it over the tabletop. Now we'll go down to the first stop, and then that little extra drop from the tip. All right, so that's how you transfer into your conical vial. We're going to put the lid on the conical vial. And of course, the lid on the reagent. You could also, put this conical vial into a beaker like this and transfer it. I guess it's up to you. It shouldn't tip over. Now, there are some cases in which we use a much thinner vial, in which case, they're tall and you might run the risk of it tipping over, but you shouldn't have any problems with this. If you're feeling a little uneasy, you could put this in a, right? But I don't think you have to use that. I think you could get along with this. Make sure you cap it and make sure you cap the reagent vial. All right. So now we've got the benzoic acid in there. You can see it on the bottom, and we're going to swirl it. That's all we're going to do. Swirly, swirly, as our lab supervisor would say. And it's going to take some time, maybe a couple of minutes. You want to keep swirling until you can still see it drop. See that? Not a drop, a crystal in the bottom. I can still see that crystal. Swirly, swirly. Until all the benzoic acid has dissolved. I'm going to pause the video so you don't have to sit there and watch it for 5 minutes. Okay, we're back. The benzoic acid has completely dissolved in the methylene dichloride, and now we're going to add 600 microliters of water. Now you've got a little 50 ml beaker. You can take your water bottle and simply add, you're only going to have to use 600 microliters, so you don't have to add much, but I would give you a decent volume so you can get that pipette tip below the surface. Okay, now I didn't change the tip. You say, well, why didn't you use another tip? Well, in the time that it took me to dissolve the benzoic acid, I guarantee there is no methylene dichloride in this tip because of the volatility of the methylene dichloride. So for this particular procedure, you don't have to change the tip. There's nothing on the surface. You can check to make sure it's secure. It's already preset for 600. We're going to get ready, and I'm going to go through a test. Notice that it's perpendicular to the desktop, not on the side. You never want to pipette like this. You're pipetting like this, right? So we're going to practice. To the first stop, plunger down the first stop, below the liquid, draw it up slowly. Perfect. Look at that, no dripping. And that's because the vapor pressure of water is a lot less than the methylene dichloride. So usually you don't have that problem. But just to make sure I've wet the inside with water, I'm going to do this a couple of times. This will be especially important when you do oils. Oils have a tendency to cling to the inside of the pipette, and therefore you want to make sure the pipette is well rinsed with the oil. Well, that looks pretty good, so we can open up this. And we can transfer very nicely and down to that second stop to get that last little drop. And we want to cap right away. I'm putting the pipette on the bench top. You know, it's not something you really want to do because this will contaminate the bench top. And when you work in the biology lab or the biochemistry lab, then you've got a problem with contaminating your sample rather than the sample contaminating you. So you got to watch out for other things. So, and you can actually buy stands. You can buy a stand that'll hold your pipette, but they're $80. Can you believe that? We're a hunk of plastic. So I'm still working on trying to get them for the lab. But in the meantime, we'll place this on the table. It's okay. All right, so we've got 2 layers in there. Top is water. Well, I told you the answer. I'm going to ask you, which is the top layer and which is the bottom? Well, how would you find out? Well, you look up the densities, right? That's why you have a table. And in that table will be shown the densities of the liquids that you're using. So in this case, methylene dichloride has got a larger density than water. So you're going to swirl these around. And you can see it kind of forms like a 2 layers. Bubbles in the center. That's actually called an emulsion. And it settles out pretty quickly. But it's kind of, sometimes these things are stable and they don't settle out. That's sometimes can be a real problem in organic chemistry when you're trying to do extractions. So just maybe give it a couple of minutes. Okay, so continuing on, we've got the water and benzoic acid and methylene dichloride in there, and we've shaken this a couple of times for a couple of minutes. And of course, the benzoic acid is distributing itself between the 2 layers. So depending on the solubility, there will be so much benzoic acid in the methylene dichloride, and there'll be another amount which will be present in the water. And the ratio of those 2 amounts is referred to as the distribution coefficient of benzoic acid in the methylene dichloride water system. Now, while that's settling out, because we're shaking it, we're going to let it settle for a while. While that's settling out, while the layers are separating, we can weigh up a drying agent. This is the sodium sulfate. So you're going to weigh up, I think it says 100 to 150, don't quote me on that. So look it up, so many milligrams of sodium sulfate, and we're going to place this in a 3 ml conical vial. You don't have to tear the vial. You have to weigh the vial. Weigh this out on a piece of weighing paper and then add it to the vial. Make sure that after you weigh this, make sure you cap it, because it is a drying agent. It will absorb water. If you don't cap it, it's going to take water out of the air. It'll absorb it, and then you'll get the hydrated form, and then it will no longer work. So you want to make sure you cap that. We're all set now to transfer only the bottom layer. We only want to transfer the bottom methylene dichloride to the drying agent. And we're going to use a Pasteur pipette, looks something like this. So you take your Pasteur pipette, a little bulb on the tip, on this end, like so. And now to make the transfer, put the two vials close to one another. And the same thing will happen as with the automatic delivery pipette. There's going to be a certain amount of vapor pressure in here that's going to build up. So you want to make the transfer as quickly as possible. So press down on the bulb, into the solution. Take a look at those films that I gave you. See how it's drawing up there? And you're going to keep some pressure on it. If you make a mistake, you will see, not really a mistake, but see the top layer? So that's what? That's water, right? So I'm still okay because the top layer is water, the bottom layer is methylene dichloride. I can still transfer. I just don't want to get any of that top layer. See the difference in the two layers? All right, so that, hopefully that is only, this is all water. And that's the methylene dichloride, and you want to cap this right away. Super. And then give it time to absorb any water that we accidentally transferred. It'll take a few minutes. Okay, folks, we're back. This has been sitting for a while. You can see the bottom part is really a solid at this point, which is good. So it's absorbed any water that we might have transferred by accident. It's also dried the methylene dichloride of any moisture that might have, the water that might have dissolved slightly in the methylene dichloride. So now we're going to transfer just the methylene dichloride, which is now dried, into a into a weighed conical vial. This is a 3 ml conical vial. I want to know the weight of this. You should not tear it. If you tear it, by the time you make the transfer, the balance will re-zero, and then you'll come over to the balance and it'll say 0. So you want to know the mass of this. If you know the mass of this, you make the transfer, we'll evaporate the methylene dichloride, and then the mass of it will be the mass of this plus the benzoic acid. So right now, there's benzoic acid in the methylene dichloride. Okay, so we're ready for the transfer. We're going to use a Pasteur pipette. You should use a clean one because this has got maybe some water in there. So we'll put this into the waste beaker. Get a fresh, clean, just be careful handling this. You're going to wear gloves. Just make sure you don't stick yourself with a corner, right? You just work carefully. You won't have a problem. Notice how I'm holding this. I'm not holding it like this, right? You hold it like this to the point it's pointing away from you, all right? And then put this on. All right, so we're all set to make the transfer. We're going to do this as quickly as possible because, again, you'll have a problem of this squirting out. So into the vial, up, keep some negative pressure on it, right out. Isn't that nice? See if we can get the last few drops. Okay, down on the bench top. And now I want to cap this. I really don't have to because as long as you transfer from here, we're going to evaporate anyway, right? But as this evaporates, it actually cools down. You can feel it's getting cool. And it'll cause moisture present in the air to condense. You'll end up with water in your benzoic acid, and then you're going to get the wrong distribution coefficient, right? Because you're going to be weighing benzoic acid and water. So cap it as quickly as possible. I can feel it's already cool, so some of it has evaporated. Okay, so we've got the methylene dichloride in a vial which has been previously weighed, and now we're going to evaporate the methylene dichloride using a hot plate. There's your hot plate. You're going to set the temperature. Whatever the boiling point of methylene dichloride is, that's the temperature you will set this for. Vial goes into this is called a sand bath. Now you don't want to put the vial in there with the cap on, right? So the first thing you do is, and you're wearing gloves, open this up. Just kind of set it down in there. Cool. Now this is important. Look at the cord. Make sure that cord does not touch the hot plate. That's a big problem. If you look at this cord, you will see there's all sorts of etching where students have accidentally had this touching. I know it's only 50 degrees, but we have experiments where you set the temperature for 250 degrees. At 250 degrees, if this touches the hot plate, it's going to start to melt. If it melts, we're going to have a short. So that's the only thing you have to be careful of using a hot plate. Make sure this is down and not touching any of the sides. Okay, folks, so we're back. This has been heating on the hot plate for a while. Let's see what it looks like. You want to get in the habit of handling things with tweezers. I mean, if I were to grab this, I know it's only 50 degrees, but what if it was 250 degrees, right? So kind of use a pair of tweezers, hold it carefully. You can see the benzoic acid on the sides. Now, if this were allowed to cool, then of course I could touch it. And you can see where it is in there. There's your benzoic acid. Now, there may be a little bit of methylene dichloride still clinging to the benzoic acid. I know the experiment says, well, look, let's break up the clumps of benzoic acid and weigh it again. I doubt whether there's much in there, but you could do that, right? It's probably a good technique for you to learn. So you're going to break up the clumps. You're going to weigh it, and then you're going to bring it back, right? Put it in the sand bath, let it go for another couple of minutes, take it back and weigh it again. And it'll be consistent in terms of its weight, but do it so you get the idea of how you perform this particular technique. And be careful when you weigh it, because if there's any sand clinging to this, right, then of course you're going to get an increase in the weight. So make sure you don't have any sand on there. But you're kind of drying to constant weight. You did that in general chemistry for one of the experiments. You had to heat something, weigh it, and heat it again. And then you heat it until you got a constant weight. So it's a similar type of technique. Okay, so that's the first lab, the calculation of a distribution coefficient for benzoic acid in the methylene dichloride water system. The calculations are in a YouTube presentation that's in the experiment itself. So take a look at the videos that I provided you with that will help you to understand what's going on. And then you've got some post-lab questions, which I expect to be turned in with the laboratory report, which will be due 1 week after you do the experiment. All right, folks,